Welcome back to Racecraft Explained, the channel where we break down the biggest Formula One stories, technical developments, and racing controversies in a simple and understandable way. Today, we are talking about something very unusual. Formula One introduced a completely new generation of cars and power units in 2026. But after only one season of experience, the sport is already preparing important changes for 2027 and 2028. Normally, a major regulation cycle is supposed to remain relatively stable for several years. Teams spend enormous amounts of time and money designing their cars around those regulations. But the 2026 cars created a major debate. Some people believe they represent the future of Formula One. They use more electrical energy, sustainable fuel, active aerodynamics, and advanced energy recovery systems. Others believe the cars have become too complicated, too dependent on battery management, and less enjoyable for the drivers. So, why is Formula One changing the rules again? What exactly will be different in 2027? And could these changes completely alter the competitive order? Let's break it all down. Why the 2026 cars created controversy. To understand the 2027 changes, we first need to understand what happened with the 2026 regulations. Formula One wanted cars that were smaller, lighter, more efficient, and more relevant to modern road car technology. The power units placed much greater importance on electrical energy. The MGUH, which recovered energy from the turbocharger, was removed. Meanwhile, the MGUK became much more powerful and responsible for a significantly larger part of the car's total output. The result was a power unit relying on an almost equal combination of combustion power and electrical power. On paper, that sounded like an impressive technical achievement, but on the circuit, it created a difficult challenge. The battery could not deliver maximum electrical power throughout an entire lap at every track. Drivers sometimes had to manage their deployment carefully, especially on circuits with long straights. That meant a driver could have enormous power at one moment and then experience a noticeable reduction later in the lap. Instead of simply attacking, drivers needed to think constantly about where to deploy energy, where to recover it, and where to accept a reduction in performance. Energy management has always existed in Formula One. Drivers have managed fuel, tires, brakes, temperatures, and battery deployment for many years. However, the concern was that energy management had become too dominant. Drivers argued that they wanted to fight one another using braking ability, positioning, tire control, and racecraft rather than losing or gaining performance mainly because of electrical deployment. There were also concerns about safety. Imagine following another car down a long straight. The driver in front suddenly runs low on electrical energy and loses acceleration much earlier than expected. The closing speed between the two cars could become significant. That is not only frustrating for the driver, it can also create an unpredictable situation. Following criticism from drivers and teams, the FIA, Formula One, and the power unit manufacturers began discussing solutions. And those discussions produced the 2027 and 2028 regulation package. The biggest change, more combustion power. The most important adjustment concerns the balance between the internal combustion engine and the electrical system. The original power distribution was close to an equal split. Starting in 2027, Formula One will move slightly away from that balance. The target for 2027 is approximately 58% power from the combustion engine and 42% from the electrical side. Then, in 2028, the split is expected to move further, reaching approximately 60% combustion and 40% electrical power. This does not mean Formula One is abandoning hybrid technology. Electrical energy will remain a major part of the power unit. The MGUK will still be extremely powerful. Energy recovery will still influence performance, and teams will still need sophisticated software and battery management systems. But the combustion engine will provide a larger and more consistent foundation for the car's power. The maximum output of the internal combustion engine is expected to increase in stages. It will rise from approximately 400 kilowatts to around 420 kilowatts in 2027, followed by approximately 450 kilowatts in 2028. At the same time, normal MGUK power is expected to be reduced to around 300 kilowatts, although the higher output available during overtaking situations is expected to remain. These changes should make the cars less dependent on electrical deployment during normal running. The officially announced objective is to allow more flat out driving, particularly in qualifying, and reduce the amount of energy management required from drivers. And that could make a huge difference. Why this could improve qualifying should be one of the purest parts of Formula One. One driver, one car, low fuel, fresh tires, and a completely open circuit. The goal should be simple: complete the fastest possible lap. But with the increased electrical demands of the 2026 power units, drivers sometimes had to plan their laps around energy. They could not necessarily use maximum power everywhere. They had to consider where the battery might run out, which sections required the greatest deployment, and where energy could be recovered. The 2027 adjustment should give drivers more consistent power throughout the lap. They will still need to manage the power unit intelligently, but there should be fewer situations where the car suddenly loses performance near the end of a long straight. That could bring qualifying closer to what fans expect: drivers pushing the car at the absolute limit from the first corner to the final corner. It could also make lap time comparisons easier to understand. When a driver loses time, viewers should be able to identify whether it came from a braking error, a poor corner exit, tire preparation, or car performance. It becomes more confusing when the main reason is invisible energy deployment happening deep inside the car's software. Formula One will always be technical, and it should be technical, but the technology should support the racing rather than overpower it. Will the cars need more fuel? Giving the combustion engine more power comes with an obvious consequence. The engine will require more fuel. To make the increased output possible, the permitted fuel flow rate will rise. The increase is expected to be around 5% in 2027 and approximately 13% by 2028 compared with the original specification. That creates an important engineering problem. Teams design their chassis, fuel tank, cooling system, packaging, weight distribution, and aerodynamics as one complete package. You cannot simply decide to carry more fuel without affecting other areas of the car. A larger fuel tank may require changes to the chassis. Extra fuel also means extra weight at the beginning of a race. That affects tire wear, braking distances, acceleration, and vehicle balance. Teams that planned to use the same basic chassis design for multiple seasons may now need to reconsider those plans. And because Formula One operates under a cost cap, teams cannot spend unlimited money redesigning their cars. This creates another challenge for the FIA. The sport wants to improve the racing, but it must also avoid forcing teams into expensive redesigns after they already invested heavily in the original rules. This is why regulation changes in Formula One are never simple. Changing one number in the rulebook can influence almost every part of the car. Energy recovery will still matter. It would be wrong to say the 2027 cars are returning to traditional engines. Hybrid performance will remain essential. In fact, the maximum amount of electrical energy that can be recovered is expected to increase. The regeneration limit is set to rise from around 350 kilowatts to approximately 400 kilowatts. That means the cars will still recover enormous amounts of energy under braking and at other points around the lap. Teams that build the most efficient recovery systems will still have an advantage. Drivers who understand how to regenerate energy without losing too much lap time will also benefit. The difference is that electrical energy should become a performance tool rather than something that constantly limits the driver. A well designed hybrid system can improve overtaking, efficiency, acceleration, and strategic variety. The problem comes when drivers are forced to slow down mainly because the system cannot maintain the required output. The 2027 changes are attempting to find the correct balance. Not zero electrical power, not a return to the past, just a more practical combination of electrical technology and flat out racing. Changes for wet conditions. Another interesting change involves boost deployment during wet or low grip conditions. Under the revised regulations, boost functionality can be used in difficult weather to prevent a reduction in power. However, it cannot be used to increase the car's maximum permitted output in those conditions. The purpose is consistency and safety rather than additional performance. Wet weather racing already places enormous demands on drivers. Visibility is limited, grip changes constantly, standing water can appear, and tire temperatures become difficult to control. Adding unpredictable reductions in power could make the car even more difficult to manage. By allowing the system to maintain a more consistent level of performance, the FIA hopes to give drivers a more predictable throttle response. Predictability is extremely important in wet conditions. A driver needs to know how much power will arrive when the accelerator is pressed. A sudden increase can create wheel spin, but an unexpected reduction can also disturb the car and affect how the driver approaches the next corner. This may sound like a small technical adjustment, but it could improve driver confidence during some of the most dangerous conditions in motorsport. Preseason testing will expand. The rule changes are not limited to the engines. Preseason testing will also expand. In 2027, teams are expected to receive 4 days of preseason testing rather than three. That additional day could be extremely valuable. With only 3 days, teams often need to divide the limited running between two drivers. One driver may receive the morning session while the other takes over in the afternoon. But conditions can change significantly throughout the day. Track temperature, wind, tire behavior, and circuit grip may all be different. That makes direct comparisons difficult. With 4 days available, each driver can potentially receive 2 more complete days of running. This gives drivers more time to understand the car and gives engineers more consistent data. It is particularly important during a new regulation cycle. Teams need to test reliability, cooling, energy recovery, aerodynamic settings, mechanical balance, tire performance, and race simulations. When testing time is limited, a single mechanical problem can destroy an entire program. One additional day will not solve every problem, but it should give teams a better opportunity to prepare properly for the season. The expanded test also helps rookies and drivers changing teams. Modern Formula One cars are extremely complicated. Drivers need time to understand steering wheel settings, braking systems, energy deployment, communication procedures, and the behavior of the car in different conditions. Simulator work is valuable, but it cannot perfectly replace real track time. Extreme heat procedures, driver safety, and extreme heat is another area receiving attention. The FIA can declare what is known as a heat hazard when conditions become dangerously hot. For 2027, that declaration can be made separately for the sprint and the main Grand Prix. Race control must communicate the decision at least 24 hours before the relevant session. This gives officials more flexibility. A sprint may take place at one time of day, while the Grand Prix may be held later under different conditions. The temperature could be manageable for one session but dangerous for another. Treating the two races separately allows officials to react more accurately rather than applying one decision to the entire weekend. Extreme heat is not simply uncomfortable for drivers. Inside the cockpit, temperatures can become severe. Drivers are wearing fire resistant clothing, gloves, boots, helmets, and safety equipment while performing at an extremely high physical level. They are also dealing with powerful forces under braking and through corners. When heat and humidity become extreme, concentration can suffer. And at Formula One speeds, even a small reduction in concentration can have serious consequences. The updated procedure is therefore an important safety improvement, even though it may not receive as much attention as the engine changes. Which teams could benefit? Now we reach the big competitive question: which teams could gain from these changes? The honest answer is that it is too early to know, but we can identify the areas that will matter. First, engine manufacturers with a strong internal combustion engine could benefit from the increased emphasis on combustion power. Efficiency, reliability, fuel consumption, cooling, and power delivery will all become even more important. Second, teams that can adapt their chassis quickly may gain an advantage. If larger fuel capacity or different cooling requirements are needed, the most flexible designs could be easier to update. Third, software will remain crucial. Even with reduced reliance on electrical deployment, the hybrid system will still be extremely powerful. The teams that manage energy recovery and deployment most efficiently could still find significant lap time. Finally, the changes could affect reliability. Increasing engine output places additional pressure on internal components. Higher fuel flow, different cooling demands, and revised deployment patterns may expose weaknesses that were not present under the original configuration. A team that produces the fastest power unit but suffers repeated failures may lose more points than it gains. The best package will need speed, efficiency, reliability, and strong integration between the engine and chassis. Is Formula One admitting it made a mistake? Some fans will look at these changes and say, Formula One got the original regulations wrong. There is some logic behind that argument. The sport spent years developing the 2026 rules. If major adjustments are needed almost immediately, perhaps the original concept was too aggressive. But there is another way to look at it. No simulation can perfectly recreate real racing. Teams can test power unit concepts on dynamometers. They can run millions of virtual laps. They can model energy deployment and aerodynamic behavior. But once 20 cars are racing together, new problems appear. Drivers discover situations that engineers did not predict. Teams find unexpected performance advantages. Different circuits expose different weaknesses. The FIA then has a choice. It can refuse to change anything and allow the problem to continue, or it can listen to the drivers, teams, manufacturers, and fans and adjust the regulations. Making corrections does not automatically mean the entire concept failed. It may simply mean the sport is learning. The most important question is whether the changes improve the racing without creating unfair costs or destroying the original sustainability goals. What about the future Y8 possibility? Beyond 2027 and 2028, Formula One is already discussing its next power unit direction. One possibility being explored is a simpler V8 engine running on fully sustainable fuel while retaining some form of electrification. That does not mean a V8 return has been confirmed. It remains part of a wider discussion about what Formula One engines should become in the next decade. The sport is trying to satisfy several different groups. Manufacturers want technology that has some relevance to their wider business. Fans want powerful, exciting cars with impressive sound. Teams want regulations that control costs. Drivers want cars that allow them to attack.